Question is, a cylindrical billet of 100 millimeter diameter and 100 millimeter length is extruded by a direct extrusion process to produce a bar of L section. The cross-sectional dimension of this L section bar are shown in the figure. The total extrusion pressure P in megapascal for the above process is related to extrusion ratio R as P equal to Ks into sigma m into 0.8 plus 1.5 ln R plus 2L by D0, where sigma m is the mean flow strength of the billet material in megapascal. L is the portion of the billet length remaining to be extruded in millimeter, and D0 is the initial diameter of the billet in millimeter, and K is the die shape factor. If the mean flow strength of the billet material is 50 megapascal and the die shape factor is 1.05, then the maximum force required at the start of the extrusion is, filling the blanks, kilonewton. Option A, 865.5 kilonewton. Option B, 2429.3 kilonewton. Option C, 2145.6 kilonewton. And option D, 1254.5 किलो न्यूटन। तो देखिए यहाँ पे एक सिलिंड्रिकल बिलेट है जिसका डायमीटर 100 मिलीमीटर है और लेंथ भी 100 मिलीमीटर है और एक्सट्रूशन की सहायता से उसे एक एल सेक्शन में कन्वर्ट किया गया है। तो सबसे पहले हम लोग डायग्राम देख लेते हैं। दिस इज द एल सेक्शन। These are the dimensions of this L section. This dimension is 10 millimeter. This dimension is 50 millimeter. And this dimension is 60 millimeter. We have got these dimensions after extrusion. This dimension is 10 millimeter. So in the question, if we will find out the original area or initial area of the cylindrical billet, तो वो हम find out कर सकते हैं। Initial area, that is AI. Initial area हम find out करेंगे तो initial area हमारा हो जाएगा pi by 4 di square, pi divided by 4 into बिलेट का डाया दिया हुआ है 100 मिलीमीटर, so 100 the whole square. So after calculating this by the help of calculator, we will get 7853.98 millimeter square initial area. So initial diameter is given as 100. We will be writing here the initial length. Initial length is given in the question. Initial length is also LI से इसको denote करते हैं. It is also given as 100 mm. So before extrusion, this was the initial area. After extrusion, we will find out the final area here. तो after extrusion, ये जो L शेप हम लोग प्राप्त किए हैं आफ्टर एक्सट्रूशन प्राप्त किए हैं। आफ्टर एक्सट्रूशन फाइनल एरिया दैट इज AF इज इक्वल टू, देखिए फाइंड आउट कर लेते हैं। This is 50 and this length is 50 and this particular section is of 10, so 50 into 10 प्लस ये भी हमारा 10 mm हो जाएगा, यहां तक ये 10 mm होगा this, so this length will be 50 and this is 10, so 50 into 10. So final area we will get AF as 500 plus 500,000 millimeter square. So here we will find out the extrusion ratio. यहाँ पे हम लोग extrusion ratio find out कर लेते हैं, क्योंकि लास्ट में हम लोगों को मैक्सिमम फोर्स रिक्वायर्ड एट द स्टार्ट ऑफ एक्सट्रूशन चाहिए। तो अभी हम लोग यहाँ से एक्सट्रूशन रेशियो फाइंड आउट कर लेते हैं। एक्सट्रूशन रेशियो स्टैंड्स एज R R is AI by AF. Initial area divided by final area. Initial area is given as 7853.98 divided by final area 1000 millimeter square. So the value of R we will get as extrusion ratio ऊपर चला जाएगा ये, तो ये हो जाएगा 7.85398. This will be the extrusion ratio. Now in the question itself they have given the total extrusion pressure. In the question they have given total extrusion pressure. So total extrusion pressure stands by this formula. P is equal to Ks into sigma m multiplied with 0.8 into 1.5 ln r. R is the extrusion ratio here. Ln r plus 2L divided by d0. 2L divided by d0. So in the question they have given sigma m is the mean flow strength. So in the question they have given the values sigma m mean flow strength, and the value of mean flow strength is 50 megapascal. In the question they have given L, this L. So L is the portion of the billet length remaining to be extruded. तो क्वेश्चन में L की वैल्यू भी दी हुई है, उसके बाद Ks भी बताया हुआ है. व्हाट इज K? K is nothing but the die shape factor, and they have given the value of die shape factor as well. Ks is equal to 1.05 die shape factor. And in the question they have given other values as well. So first of all we will be finding this particular pressure, this particular total extrusion pressure. When we will be able to find out this total extrusion pressure, then by multiplying this extrusion pressure with the initial area, we will be able to find out the minimum force required at the start of the extrusion. So here total extrusion pressure is given as Ks into sigma m whole multiplied with 0.8 plus 1.5 into ln r plus 2L by d0. So the given quantities are R, the value of R, that is extrusion ratio, that is extrusion ratio AI by AF, initial area by final area. So it is 7.85398. Length is given as 100 mm, and mean flow strength is given as 50 megapascal. D0 is 100 millimeter, and the die shape factor is given as 1.05. So we will solve it. So total extrusion pressure P will be 1.05. Ks is 1.05 into 50 megapascal, that is mean flow strength, into 0.8 plus 1.5 ln. The value of R is 7.8539 plus 2 into the value of L is given as 100 and D0 is also 100. So when we will solve it by the help of calculator, then we will get the value of total extrusion pressure in megapascal as 309.296 megapascal. Now we have to find out the maximum force required at the start of extrusion. So now we have to find out maximum force at the start of the extrusion. So force will be equal to total extrusion pressure, that is P, into initial area AI. So we will calculate this. Pressure is 309.296 and initial area is given as 7853.98. So when we will solve it, By the help of calculator, we will get it 2429278.72 Newton. 0.72 Newton. But here in the question, they have asked the maximum force at the start of the extrusion in kilonewton. So it will be F is equal to 2429.27872 kilo Newton. So this will be our final answer. So in this question, option B will be the correct answer, 2429.3.